Poliomyelitis was a crippling disease, a summer plague. It feared many parents in the world. Poliomyelitis was an infection caused by the poliovirus, which was caused by an enterovirus. This is a virus that typically occurs in the gastrointestinal tract. Poliomyelitis is a crippling and deadly virus that invades the nervous system and causes irreversible paralysis. Polio was the cause of the daily deaths of children and thousands yearly. Hence why it became an epidemic. Polio would come back at the same time every year and infect thousands, mostly children. No one knew what caused it, but everyone had their own theory. There was no prevention or cure. Poliomyelitis was highly contagious as it spread through direct contact, hence why it mainly affected children. It left thousands of children in wheelchairs and limb braces and breathing machines. This is why it became an epidemic. In this diagram, we'll be showing the human immune system with the polio vaccination and how it reacts to the pathogen entering the body. So firstly, we have a child with the vaccination, the polio vaccination, playing in a sandpit with one infected toy with the polio virus. The polio virus ends up going into their mouth as the toy went into the child's mouth. Immediately, the neutrophils, dendritic cells, natural killer cells, and macrophages are stimulated to fight the antigen. They move towards the antigen and begin to perforate the cell, the infected cell. The cell then begins to die off, and the pathogen does not survive. This means that the child has no infection, hence the smiley face. In this second model, we'll be looking at how a child's immune system reacts to the polio pathogen without the vaccination. Same scenario, a child puts an infected toy in their mouth and the polio virus enters. This causes antibodies to begin to react to the anti-agent. Second line of defense, also known as the innate immunity, begin to respond. Dendritic cells, neutrophils, natural killer cells, and macrophages all attack the pathogen. Due to how foreign the pathogen is, the second line of defense will be unsuccessful in killing the pathogen. Macrophages then either turn into T cells or B cells, which are leukocytes and lymphocytes. The helper T cell then begins to react, stimulating the immune system to the antigens. 3 receptors are stimulated to assist in killing the pathogen. The first receptor is a killer T cell. A killer T cell recognizes the infected body cells with an intracellular pathogen and then releases a cytotoxin called perforin. This means it perforates the cell. As we can see, the cytotoxin is multiplying and attempting to perforate the infected cell. However, this will be unsuccessful. At the same time, a memory T cell will be stimulated. This remains in the body and allows for a more effective response. The final T cell stimulated is the suppressor T cell. This inhibits immune cells at the end of the immune response. They also multiply. This increases future immunity. B cells will now be stimulated. The 2 B cells are plasma and memory. Plasma B cells mass produce the same antibody to strengthen the immune system and attack against the antigen. Whereas memory B cells remain in the body for a long time in order to provide future immunity. They do this through multiplying. If these cells are not successful in fighting the anti-agent, it will mean that the child will begin to show signs of polio or the infection. The child could then potentially experience paralysis and the worst of the infection. The virus would then reproduce in the child's mouth and intestines, then travel into the blood and invade the nervous system, specifically trying to kill the anterior horn cell. This is the front column of grey matter in the spinal cord. When that cell is killed, paralysis occurs. The paralysis is also affecting breathing of some children. Hence the breathing machines that they are placed in for weeks until they can contract their own diaphragm. Through all this highlights how effective the vaccination is for poliomyelitis. It stimulates the immune system with the dead antigen so that their memory B cells can remember how to fight off the antigen, as well as stimulating the second line of defense, increasing immunity. This model is an effective procedure to stop the spread of disease as it highlights how different the immune systems will respond with or without the vaccination. There's a clear distinguishment between how both of the children's immune system responded. Child A's second line of defense immediately acted due to the memory B cells and killed the pathogen before it could multiply in the blood and infect the whole body. Whereas child B, the second line of defense, suspected a foreign substance and were unable to kill the pathogen before it entered the blood. Hence, the pathogen multiplied in the bloodstream and infected the whole body and caused poliomyelitis.